So, today we're diving into something that feels like it's straight out of science fiction. It's where artificial intelligence is starting to understand the most personal thing about us, our health. We're going to look at a new kind of AI that tries to read the story of your health and predict what happens in the next chapter.
I mean, just think about that for a second. What if an AI could look at your medical history and actually predict the diseases you're likely to get down the road? It sounds impossible, right? A person's health is this giant, messy web of genetics, lifestyle, chance, all tangled together over a lifetime. Trying to predict what comes next is, well, it's one of the toughest challenges in all of medicine. But that's exactly what a new model called Delphi-2M is being designed to do. Its whole purpose is to find the hidden patterns in how human diseases develop over time. It's basically learning to read our lives, but as a sequence of health events.
So how on earth does it work? Well, let me give you an analogy that you're probably already familiar with. You know ChatGPT, right? It's a type of AI called a generative transformer, and it's amazing at predicting the next word in a sentence. Delphi-2M is built on that same idea, but instead of predicting words, it's trying to predict the next health event in the story of a person's life.
Okay, let's break that down. First, it takes in all of a person's available health data. Then, it reads that history just like a story, a sequence of events, diagnoses, checkups, lifestyle factors, you name it. From that sequence, it predicts what disease is most likely to come next. And here's the really crucial part. It also predicts when it might happen.
Now, to learn something this complicated, you need a massive amount of data, and they had it. The model was trained on the super detailed health histories of more than 400,000 people from the UK Biobank. That incredible scale is what gives it such a solid foundation to even begin to understand the complex dance of human health.
Okay, so that's the theory. But the real question, the one that really matters, is how well does it actually work? I mean, a prediction is useless if it's wrong. So let's take a look at the actual performance.
To do that, we just need to understand one little metric, the AUC score. The easiest way to think of it is like a grade. A score of 1.0 is a perfect score, an A+. You can't do better. A score of 0.5 is basically a coin flip, just random guessing. So the closer you get to 1.0, the better the prediction. So what did the model get? Well, when it came to predicting mortality, one of the most significant health outcomes there is, Delphi-2M scored an AUC of 0.97. That is unbelievably close to a perfect prediction. It's honestly kind of shocking.
And this table here really shows you how it stacks up against the tools that doctors are using today. For heart disease, it's basically neck and neck with the standard clinical score. Same thing for dementia. It's right there with the best tool they've got. But look at this last one. For predicting death over a longer period, it's actually better than the standard Charlson score that's used all the time. This thing isn't just a science experiment, it's performing at or even above the current clinical standard.
But predicting the next event is only half the story. The part that's truly futuristic, the part that really blows your mind, is that it can do more than just predict the next step. It can try to map out the entire rest of the journey.
This is what we mean by generative. It can take your health history up to today, and then it can generate a plausible story of what might come next, creating a whole simulated narrative of your future health for years and years to come.
Let's make that real with an example. Imagine we feed the AI someone's entire health history up to the age of 60. The model could then generate a potential future that looks something like this. Hypertension at age 65, then osteoporosis at 71, atrial fibrillation shows up at 78, dementia at 82, and eventually death at 85. It generates a complete, simulated life story.
So why is this a big deal? I mean, who cares about a fake health history? Well, it's actually a game changer. For researchers, it lets them study how diseases might play out over decades. It also lets them create huge amounts of realistic but totally anonymous, synthetic data. This is amazing because it helps protect patient privacy while still letting us train other AIs. And for governments, it could help them estimate the future healthcare needs of an entire country.
Okay, before we get too excited, we have to hit pause. With any AI this powerful, we absolutely have to talk about the limitations, the risks, and the biases, because this is not a perfect crystal ball. It has some very real flaws that we need to understand.
The researchers who built it said it best in their paper. They said, the AI is a mirror. It learns and reflects the patterns and the imperfections of the data it is trained on. And that is the key. The AI doesn't invent bias out of thin air. It learns the biases that already exist in our society and in our healthcare data.
So here's a huge one, the healthy volunteer bias. Think about it.
The people who sign up for these huge long-term health studies, like the UK Biobank, aren't a perfect representation of everybody. They tend to be a bit healthier, a bit wealthier, and less diverse than the population as a whole. So the AI is an expert on that group of people, not necessarily everyone.
It also learns weird quirks from how the data gets collected. For example, the AI figured out that if a person has one diagnosis that came from a hospital record, they are 10 times more likely to get another one. Now, that's not some deep biological truth, it's a data pattern. The model just learned that people who go to hospitals get things written down in hospital records. It's reflecting the system, not just the science.
So, where does that leave us? This technology is incredibly powerful, for sure, but it's not some all-knowing oracle. The way to think about it is as a really, really smart tool that's meant to help human experts, not replace them.
The future possibilities are huge. You could use this to find patients who need to be screened for a disease early, way before they'd normally qualify. You could help governments figure out what diseases are going to be a big problem in 20 years, and you could give doctors another powerful tool to help them make really tough calls.
And this right here is the single most important takeaway. This kind of AI is not an autopilot for medicine. It's a co-pilot. It's designed to analyze tons of complex data and offer insights to support the wisdom and the experience of actual doctors and scientists.
So, that brings us to one last question. And this one isn't about the technology, it's about us. If an AI like this could draw you a map of your most likely health future, the diseases you might get, and when, would you actually want to look?